Started. Started.
Yeah, yeah.
Hello, sir. It's me, Amit Kumar Singh, 19 BC 2611, with my teammates.
19 BC 048 Ayush Khare.
19 BC 2672 Lokesh Mishra.
19 BC 2235 Sai Tharun Kumar.
NBC 2224 Madesh Pretam.
So our project title is Sir ARP Poison Prevention and Detection System. So the basic idea of our project is we are using a two PCs. One is the attacker PC, that will be the our Kali Linux machine, and the other one will be our Windows machine. The basic idea is like first the attacker will create a man in the middle and poison its ARP table of a window machine, and then it will steal all the sensitive information like the credential or any packet or a ping or any surf will be sent, or any packets will be sent from a attackers or from the victim machine to the access point, and then it will capture all those packets and all those sensitive information, and it will return and use for their its own sake the hacker machine. It will create a mediator between the access point and the victim's machine. So the basic idea is this, and we will also gonna prevent this by using some script, and it will be gonna implement it later. So without wasting time, I gonna take over the this introductory part to my friend Madesh, and he will be continuing with it. Madesh.
Good evening, sir. This is Madesh. And the basic terms in ARP poisoning are the ARP, which is a procedure for mapping a dynamic IP address to a permanent physical machine address in a local area network. And in information security, the process and methodologies which are designed and implemented by to protect print and electronics, and the UDP, a lightweight data transport protocol that works on top of IP. Next. And the ARP cache, after resolving MAC address, and the ARP sends it to the source, and when it stores in a table for further reference, and the subsequent communications can use the MAC address from the table. And the ARP cache timeout, it indicates the time for which the MAC address in the ARP cache can reside, and the ARP request. This is nothing but the broadcasting a packet over the network to validate whether we can come across a destination MAC address or not. And about the ARP spoofing, it's also called as ARP poisoning, which is a type of cyber attack over a LAN that includes sending malicious ARP bundles and using the ARP protocol to transmit malicious ARP messages to the destination network. And it is also called ARP table. And the ARP protocol translates IP address into MAC address. Next. The important terms are the ARP spoofing, ARP, and MITM. And ARP spoofing is a type of attack in which a malicious actor sends falsified ARP. And in ARP, it is a procedure for mapping a dynamic IP address to a permanent physical machine address. And the MITM, it's a general term when a perpetrator positions himself in a conversation between a user and an application, either to eavesdrop or to impersonate one of the properties. And about the ARP spoofing, in this, the attacker itself comprises of an attacker with sending a false ARP response to a default network gateway and informing it is that or her MAC address ought to be related with her target's IP address. When the default gateway has received this message and broadcast, it changes it to all different devices on the network. These all of the targets traffic to other devices on the network, and since the ARP poisoning attacks happen on such a low level, users targeted by ARP poisoning rarely realize that their traffic is being accessed or altered. And
So
the
now,
select Ayush is going to continue.
yeah. So now, sir, for the related like papers we have seen, like the first one is by Jaideep and Dhariwal, and 2017. It's a detailed survey of ARV poisoning detection and mitigation techniques. And the approach in this paper discussed about the ARP attacks and many other attacks, and talks about how and man in the middle attack happens. It also discusses various detection and mitigation methods. They have introduced us a lot of software used for mitigations like ARP Watch and ZAP, etc. But the demerit, or the thing which was not present in this paper, was they concluded that that there are still no definitive preventive methods that can be shown by them. Like they cannot find anyone. And the second paper we had was the address resolution protocol spoofing attack with security approaches. So it is a survey by Mohammed S. Obatet, and it is from 10th December 2018. So the approach for this paper was they provided an efficient and secure way to mitigate ARP attacks and detect ARP poisonings that can reduce the attack. And paper also discusses about various effective approaches and security issues in ARP spoofing. But in this paper, what they had was they had to detect the attack first, then they could prevent it. Without a detection, the prevention could not happen. So the third paper we had was by S. Bridul and V. Katak, and it was a lightweight approach for IP ARP spoofing detection and prevention. So in this paper, they gave us some basic information about ARP spoofing. ARP spoofing may be used to launch using following attacks like DDoS attacks or man in the middle. After introducing this ARP spoofing, it also provides several techniques used to figure out how to do the ARP spoofing. So the demerit for this paper was it only showed us about the simulation of the ARP spoofing without actual prevention. It just theory prevention was provided. And so the problem statement for our project was we do some examination and simulation about the ARP address resolution protocol and ARP spoofing to exhibit a few precautions in ARP, and finally we prevent this using script. So objectives in this project was to prove the vulnerability of ARP protocol by simulating valid ARP replies and spoofing, and compare the results, analyze the behavior of different nodes in both the cases. And we also wanted to remove HTTPS from the sites like Web and Stock Overflow, and get the credentials of the users logged into the website. We also want to gather the information about the web pages which the victims was visiting during the attack. So these are the some few terms were like shown in the introduction, but these are the other terms we'll come across throughout the thing. So first was the AIP cache, and after resolving MAC addresses and ARP sends this to the source where it stores the for the future references. AIP cache timeout, it indicates the time for which the MAC address in the ARP cache can reside, and ARP request, this is nothing but the broadcasting the packet over a network. The physical address of a sender, the IP address of a sender, the IP address of the receiver will be in this format with ones. An IP address of the receiver will also be in this format, and ARP responses, which is the MAC address response that the source receives from the destination, which aids in further communication of the data. So these are some of the tools that can be used for ARP spoofing attacks: BetaCap, ARP spoof, AR Poison, Subterf, Verge, or these many. But we will be using DNS sniffer. So after, from the design, Lokesh will speak.
Okay, so hello sir, I'm Lokesh and I'll be continuing on with the presentation here onwards. So in this slide, as it is clearly visible, we have implemented a kind of architecture how actually our project will be implemented. So as we know that this ARP protocol is basically used in order to retrieve the MAC address of the target machine. So from the first image we can see like the machine A actually wants to know who's the one with the address 10.0.2.6. So the first step is that it will check in its own ARP cache. If that particular address is already present there, then directly the communication will start and proceed further. And if it's not there, then the thing will happen is that it will broadcast it to the entire network. Now after every network they get this request like asking someone is asking who has this particular address. So the target machine which we want, or the one from whose MAC address we actually want to know, that particular machine will respond sending their messages to the one that is asking. So this is the only thing that is being displayed over here. So the machine A is asking like in other ways it's broadcasting basically who has this address 10.0.2.6. Then the machine C, it says that I have this particular IP address, and in response they give back their MAC address. Now since after the MAC address is retrieved, they can start transferring data and then communicating. Another thing that actually we are implementing is ARP spoofing, where we know that there comes in a man in the middle who tries to act like the target machine, but actually isn't the target machine, and thereby extracting all the data that has to be sent to some other machine, but that particular machine instance acts like the target. So we can see like in normal ways there is a victim and the resource engagement. So only between these two particular systems the data is being transferred. But when some third party, or you can say a man in the middle, that kind of attack is applied here, so they become an somewhere in the middle. So all the messages that are being transferred, they go through them. So in this way, this cyber attack is implemented, and systems like the owner's security is under risk. Now this is basically the implementation of the attack that we are doing. So the victim, which of course doesn't know what actually is happening behind the scene, they make a request. Now that machine is waiting for a response from some other target machine saying that yes, I am from this IP address and here is my MAC address. But in the middle comes the hacker who falsely replies or sends a response back saying that yes, I am the target machine, which actually is not. Now after receiving that MAC address, the victim and that hacker, they start communicating. So in this way, being hidden from the original victim, this hacker implements this, takes advantage of the working of the ARP protocol, and thereby gathers all the data which had to be going to the target machine, but actually this isn't happening right now. So here is the algorithm which simply explains what's going on. So the step one is like when one machine needs to communicate with another, it looks into its ARP table. This is the basic thing. They'll check in their ARP cache. If it's there, then they'll proceed further. Otherwise, then we go to the next step, which is that that particular machine will broadcast its message into the entire network, asking who is this particular IP address machine, and in response, that particular machine has to send their MAC address for the communication to begin. Now, all machines in the organization will compare this IP address with MAC address. If one of the devices in the network identifies this MAC address, then it will respond to the ARP request with its IP and MAC address. And the requesting PC, that is our host machine, you can say, will store this address pair in its ARP table, and communication will occur. The key thing to note here that they are particularly storing it in the cache, so that next time again if they want to communicate, they'll first go through the ARP cache. Otherwise, only they'll broadcast it to the entire network. Now, implementation of ARP spoofing attack, again, this is a particular example of that. The IP address of Windows machine can be seen in the following images: 192.168.29.10. This basically will show in the implementation further. And all the devices connected to the same Wi-Fi are visible in the following image. Now, before attack, Windows machine with IP this one is sending data to physical address 94FB A7698B C5. And after attack, IP address of the Windows machine 192.168.29.10 is now sending data through the physical address this one, which is the physical address of the attacker's device, which we obviously refer to as the man in the middle. So physical address of the attacker's device is this one, 00367601B785, and this is the basic implementation. They are basically capturing all the data, and this is a diagrammatic or pictorial representation of what we are doing. Now coming to the hardware and the software requirements that we require over here in our project is first we need PCAP, which basically is a packet capture library providing a high level interface to the packet capture systems. In this, all the packets on the network, even those destined for other hosts, are accessible through this mechanism, and it also supports saving captured packets to a safe file and reading packets from a safe file. Next thing we require here is a Linux system. Linux operating system is family of the open source Unix like OS based on the Linux kernel, which was an operating system first released in September 1991 by Linus Torvalds, and we'll be using Linux and Windows as two of our major machines for implementing this ARP spoofing attack. Also, we require Wireshark as a software. Wireshark basically keeps track of all the packets that are being sending from one device to another. So this way we can see like actually the packet from the host machine to the target machine, it's going straight away to in this between these two routes only, or there is some particular man in the middle through which this particular packets are going. So we can track it out using the Wireshark software. And of course we also have a DNS sniffer, which basically used to figure out the DNS of the attack that we are implementing over here. We'll show all these things in the implementation further. Now from here onwards, my friend Sai Tharun will continue. Thank you.
Good evening, sir. This is Tharun. So here we have attached a few snapshots of our implementation, which will be showing in the demo. Uh, Next, coming to the part. So this is the result analysis part. So here the final result analysis is based on the prevention of ARP spoofing attack. So here firstly we ensure that there is no attack on system by getting the default gateway MAC address and also the IP address. Next we find and set up a device on which we will do the DNS sniffing. Next we open a device for a sniffing session. So here since we have a particular packets, we need to filter the traffic for ARP so that we use the PCAP loop for each packet that we receive. Next, we get into the packet's SW address and IP address. So, if the packet's hardware and default hardware are equal, then the packet IP address and also the default IP address is same. Then we will block that ARP packet and re-ARP it back. So, if the defender is stopped, then we flush the ARP table. So this is the prevention of ARP spoofing attack. So here again we have attached snapshots of them. Next coming to the so next finally coming to the conclusion part. So here we have successfully used the ARP spoofing to show the risks which are involved in having an MITM attack, like getting a password or etc. So that it basically leads to a data leakage without the user's intention. So to prevent the ARP attack, we have written a script using PCAP and API for sniffing packets and blocking the ARP attack. Next, coming to the future enhancements, we can also do a new type of ARP spoofing mechanism, so that can be implemented, which is more preventive and efficient. So we also know a newly developed detection scheme for ARP spoofing based on routing trace. So that can be a future enhancement. Next, next, we will be attaching a YouTube video presentation link here. So coming to the references, we have gathered new research papers and followed them to do our project. So these are the research paper mentioned. So this is the our presentation. Thank you, sir.
Hello sir, it's me Amit Kumar Singh, 19 BC 2611. I'll be gonna demonstrating our project. So coming to this, we have used two PCs. One is our attacker's PC and second one is our victim's PC. We have taken attacker's PC as a Kali Linux machine, this one, and the victim's machine as a window machine. So we will be like, first we will check what the IP address of our victim machine. So to do that we will use CMD. So we use IP config to check what IP addresses we have. So the victim machine followed the IP address of 172.17.8.243 with the default gateway followed by 8.1. So before attacking we will check the ARP table, the original ARP table. So we can see the ARP table having this router, this router associated with it, and the MAC address as well. So this is the this is the IP address of the victim's PC, and followed by the MAC address which is 6D at the last, and this we will be poisoning it by attacking. So we will poison this ARP table and give the MAC address of the victim, and to steal its sensitive data and information. So coming to the Kali, we have to check what IP address does have a Kali machine we have. So ifconfig. So our attacker PC followed the IP address of 172.17.15.89, and its MAC address is followed by BC, which we will use for poisoning the MAC address of the victim. Now to do that we will create a man in the middle by using the sudo -i, which enables a super user in a Kali. So the password is 455229112. So we are in the super user mode. So to 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 forward the packet, we will be using this command echo greater than 1 proc system slash net slash IPv4 to forward the packets in IPv4. So we will be using this. And to sniff the to attack the address, to attack the PC, we will be using a ARP snoof, which is the part of a DNS snoof. So we use poof dash I is an interface from which we have want to attack, and D is our target, which will be the Windows machine IP address 172.17.8.243, and our R will be the R will be the default gateway of the victim's machine 8.1. So here we can see it's sending some replies of changing the ARPs as a BC. BC is the MAC address of this, which we will poison. It started poisoning the ARP table of a victim machine. So coming to the ARP table of victim, we can again request for a ARP table ARP-A. Now we can easily see the changes from the PC. The ARP table of this window PC have been poisoned. 172.17.81 follows by BC. Well, before it was ED 68 and having the MAC address of 68. Now any information or anything, any web surf or any packet or ping will be requested from the victim's PC, will be first sent to the attacker's PC and then to the server or access point. So to capture all those packets and see what the sensitive information or any data have been sent by the user to sent by the victim's PC, we can capture all those packets by using Wireshark tool. To capture all those packets, we will use Wireshark tool, and we select Ethernet 0 because we can see there is a traffic, and we also have used this interface Ethernet 0 for attacking the PC. So we will be just clicking that, and we can see the packets have been started being captured with 156 197. The packet have been started being captured. Now what we will do is we will come to the Windows PC, and we will go for the try for logging in some credentials. So we have used some HTTP on secured website. So I will be just demonstrating it by using my registration number 19 BCE2611 and username as the username I have kept. So I'll try logging in with it. It takes some time because it's fully loaded with. I'm doing it in the same network, and same attacker and same this have been used in the both. So it's taking some time. Oh, it's load. The site cannot be reached it, but actually the packets have been sent to the access point. Now we just need to go and check for the our window packet tracer, so we can check the packet. So as we can see, we have captured lot of packages. Among them we have to look for the HTTP ones. HTTP, we will search for HTTP because the site was unsecured, and we have to look for the credential, the victim's credential. So we will go in the post logging. Here it is, the post logging part, and then followed then TCP stream, and then we can find what the victim have used as username as an admin and password as 19BC2611. So we are successfully able to fetch the harvest data of and credential of the victim's PC. So here, now coming to the prevention part, we can go. Yeah, now coming to the defender part, now we have to check whether we can defend the ARP snoof attack or not. So we need to go to the attack victim's PC, and victims have the now we have a script here. So the script is like, I'll be explaining what the script is doing basically. The script is like, yeah. So it what it does is like, it set first it takes the all the ARP tables as and set a name as a ARP, and takes as one of the input file, one as the input file, and then it compares with the modified one ARP table, and if it gets a file input and output file is same, then it goes to the, like, it go in looping, and if there is any changes, it raises a token, and dumps the network and disable your Wi-Fi adapter, and shows the mess and print the message as duplicate IP address found, and then it restart your adapter, and then we can go for a new MAC address. Then again the ARP will be again fetch and request by the access point, and again the same, and the original ARP will be stored. So in this way we will defend our ARP snoof. So running this, we can see like no MAC snooping detected till now. So till now that file have compared with original MAC, original snoof ARP table, and the now ARP table. So it's the continuous looping process. So it's the continued looping process. Now we will try getting the ARP snoof. So when we try to attack the address, it compares the file, and it will show that 172.17 was found with a duplicate MAC address, and just now it will disable the Wi-Fi interface of that, and again reconnect it and apply for a new ARP table. So in this way it was completed. Thank you, sir.